Hey students, welcome back to Vedantu NCERT Solutions class 11th and 12th. This is Suhas, your chemistry master teacher. Students, in this video we discuss the solution for the NCERT question 9.1 from the unit Amines. Let's move on to the question. The question is, write IUPAC names of the following compounds and also classify them into primary, secondary and tertiary amines. Let's move on to the first one. The first one, let's write the structure of this compound. The structure of this compound like this, right students? CHNH2. Here CH2 group is there. That's why the compound structure is this. We also need to classify them into primary, secondary, tertiary. In this compound, amine group is nothing but N group is only attached to one different R group. That's why this compound becomes primary amines, right? Primary amines. This compound is a primary amine. Let's move to the IUPAC system. Here totally 2 carbon atom is there, and also at first position NH2 group is there. That's why, and also first position methyl substitution is there. We already know IUPAC system is divided into 3 parts: prefix, suffix and also parent carbon in mid. That's why parent carbon is nothing but ethane, right? Ethane. At one position amine is there. That's why E is replaced by amine. Ethane, 1 amine. And also first position methyl substitution is there. That's why the final compound name becomes 1-methyl ethane 1-amine or 1-methyl ethanamine. Let's move to the second term. The second term, let's write the structure. CH2 is there, right? NH2. But if we write like this, this carbon group is not satisfied, students. Let's check. Yes, it's satisfied, right? Let's move on to the classification. This is a primary amine. Why? This in this compound the NH2 group is attached only for one different R group. That's why it's a primary amine compound. Let's move to the IUPAC system. There is totally 3 carbon atom is there. That's why propane at first position amine group is there, right students? This is an IUPAC name. Let's move on to the third one. Let's write the structure. CH3 NH CH3 and CH3. This is a compound. This is a structure of the compound, right? Here N group, amine group is attached to 2 different R group and 1 hydrogen group. What is the valency of nitrogen? It's 3, right? 3 and 5 depends upon their valence, depends upon their counter ion, right? That's why it's an H group is N group is attached to 2 different R group. That's why this compound is a secondary amine compound, right? It's S. Let's move to the IUPAC system. Naming. At N position CH3 group is there. Totally 2 carbon atom is there, right students? It's nothing but ethanamine. Last term is becomes ethanamine. Suffix term becomes ethanamine. Let's move on to the prefix term. Here methyl group is there, and also here CH3 and another methyl group is there. That's why let's make the naming 1, 2, 3. The naming become like this, right? At first position N group CH3 group is there. That's why the final compound name becomes N-methyl. At second position methyl group is there. Yes, absolutely. Second 2-methyl ethanamine. The final compound name like this. Okay, understood? If you have any doubt, let me know in comment section, students. Let's move on to the next compound. CNH2, and here 3 it attached to 3 different CH3 group. This is an primary compound, right students? It is also a primary amine. Why? Because the nitrogen group is attached to only one different compound. Here totally how many carbon atom is there? Totally 1, 2 is there, right? Let's move on to the IUPAC term. Before moving to the IUPAC term, we already classified into primary amine. Here we need to count the number of carbon atom. Here highest number carbon chain contain 3 carbon atom is nothing but prop. And first position amine group is there. That's why propane. At not in first position, students, 1, 2, 3. At second position amine group is there. Please do not confuse. Propane 2 amine. And next move to the prefix term. Here at 1 CH3 group is there in substituent part. That's why at second position substituent 2-methyl propane 2 amine. Understood students? Let's move to the next term. C6H5NHCl3. The structure of this compound is C6H5 is nothing but benzene ring, and 1 nitrogen group is attached and another CH3 group is attached. Students, this compound is a secondary amine, right? Why? Because N group is attached to 2 different R group. One R group is an benzene group and another one is methyl group. Then let's move on to the IUPAC term. It is a secondary amine compound. IUPAC term. Students, we already know this term, NH2 term. We call this as an aniline. Its IUPAC name is an aniline. We can also name like otherwise N methyl, CH3 is nothing but methyl aniline, or N-methyl benzamine. N-methyl benzamine. These are the two names of this compound. We can also name as an aniline or benzamine. Understood, students? Let's move on to the next term, NCH3, and this two group is there, CH2CH3 and also CH2CH3, right? This is an, that's why N group is attached to three different, not in three, three different R group. That's why it's become tertiary amine. This compound is become tertiary amine. Let's move on to the IUPAC system. At N position, methyl group is there, N-methyl, and also, but here another group is there. We need to count the parent chain. Here two carbon atom is present in this, but another ethyl group, we miss the ethyl group. That's why the name becomes N-ethyl, right? N-methyl ethanamine. Final name becomes N-ethyl ethanamine. Understood, students? Let's move on to the last term, metabromo C6H5. Let's write the structure of this compound. Benzene group is there at meta position. This is a meta position, Br group. Here NH2 group is there. This is a structure of the compound. We already know these groups are ortho, meta and para position. Right, students? We already know. Let's move on to the IUPAC system. Before entering to the IUPAC system, let's check it is primary, secondary and tertiary. Here N group is attached to one different R group. That's why this is a primary amine compound. This is a primary amine compound, as it's absolutely right. Let's move on to the naming. The numbering takes place from this side. That's why the final compound name becomes 3-bromo benzamine, or we already discussed same question, same position, C6H4 and NH2. What we call this group as an aniline group. That's why it is also called as an 3-bromo aniline. Understood, student? If you have any doubt, let me know on comment section. Give one chemical test to distinguish between the following pairs of compound. First, move on to the first pair, methylamine and dimethylamine. Here, methylamine. What is the structure of methylamine? The structure of methylamine is CH3NH2, right? It is an primary amine. Second one, dimethylamine. What is the structure? CH3N, CH3. Another H molecule is there. This is a structure of dimethylamine, right? As it is a secondary amine. We already know. We can easily differentiate primary and secondary by using carbalamine test. What is carbalamine test? If the primary amine is heated with, for example, here methylamine is there now. CH3NH2 is heated with chloroform, CHCl3, in the presence of potassium hydroxide, to yield foul smell isocyanate compound. Foul smell isocyanate is nothing but CH3NC compound with KCl molecule and water molecule. Let's balance the equation to balancing. This is a reaction. Understood, students? Let's move on to the second one, secondary and tertiary amine. Here we differentiate first primary and secondary. If in this place primary and secondary is there, we can easily differentiate by carbalamine test. Secondary and tertiary, we can easily differentiate by which test? From using Innsberg reagent. What is Innsberg reagent? What it will be yield? What, students? The benzene sulfonyl chloride compound is called benzene. This, right? This compound is called Innsberg reagent. If this compound is reacted with this compound is reacted with secondary molecule and it gives positive test for Innsberg reagent. Secondary molecule, secondary amines, it gives positive test. For example, let's take secondary amines. This is a secondary amine, right, student? What is secondary amines? It's nothing but in secondary amine compound only it is different. It is here 2R group is present. 2R group is replaced 2 hydrogen, right, students? And it is reacted with this compound, benzyl sulfonyl compound. Benzyl sulfonyl compound. What it will yield? If it reacted, this HCl molecule is releases and it forms a new molecule, benzyl sulfonyl product. It forms a benzyl sulfonyl product. Here N C6H5 and C6H5 with the release of HCl. What is the name of this? N diphenyl, right? N diphenyl benzyl sulfonide. Understood, students? Let's move on to the third one, ethyl amine and aniline. What is the structure of ethyl amine? Ethyl is ethane, 2 molecules, CH3, CH2, NH2, right? And aniline, this is, students, this is an aliphatic amines, this is an aromatic amine. Which test is suitable for aliphatic and aromatic? Any idea? We can easily differentiate by azodite test. What is azodite test? For example, what aromatic compound gives positive for the azodite test, but not an ethylamine or aliphatic compound, right students? If aniline is reacted with NaNO2 in the presence of dilute HCl, if it is heated with, it yields one unstable compound. What it yields? It yields one unstable compound, N2 plus minus Cl minus. If it is further on reacted with beta naphthol, what is the structure of beta naphthol? At beta position, OH group is there, right? Alpha beta. At beta position, OH group is there. It is an beta naphthol. It yields dye, orange dye. It yields orange dye, students. What is the structure? What it will yield? It yields this, right? N2 molecule, Cl molecule get cancelled, double bond N, this OH molecule, and it yield this structure. Yes, absolutely. Next, more the next one, aniline and benzylamine. What is the difference between aniline and benzylamine? Both are not in same. Aniline is an NH2 group is directly attached to aromatic ring, but in benzylamine it is attached to CH group. The CH group is directly attached to what? CH group is directly attached to aromatic hydrocarbon, right? Aromatic ring. Same procedure, students, same azodite test, we can easily identify, we can easily differentiate both this. If aniline compound undergo azodite test, it is dye compound, it is same dye, but it is N2Cl minus, right students? It is unstable on compound. But similarly, benzylamine, if benzylamine is reacted with NaNO2 and dilute HCl, NaNO2 and dilute HCl, what it yield? It is alcohol, student. First it is unsaturated compound CH2 students. Why? Yes, CH2 NH2, right? CH2 N, first it yield N2 plus Cl minus, right? N2 plus Cl minus, then further on it releases N2 gas, but here N2 gas is not releases. Understood? Here N2 gas is releases. In aniline compound it's not releases. Let's move on to the next one, last one, aniline and N-methyl aniline. What is the structure of aniline? The structure of aniline is this one, but N-methyl aniline, it's nothing but one hydrogen is replaced by CH3 group, NH. Students, it is very easy. It's a primary amine compound. This is a secondary amine compound. By using carbalamine test, we can easily differentiate this pair. What happened if aniline is undergo carbalamine test? Carbalamine test is nothing but it is heated with chloroform and KOH. It is isocyanate. It is isocyanate, right? What it is? C6H5 NC compound, isocyanate, foul smell isocyanate compound with release of KCl molecule and H2O molecule. Okay, understood students? We need to account for the following. First one is pKb of aniline is more than that of methylamine. pKb is nothing but basic value, basic strength value of aniline. What is the structure of aniline? The structure of aniline is this, right? This is an structure of aniline compound. And methylamine is nothing but this one. Students, here please if CH3 group is an electron donating group, that's why it shows positive I effect. That's why pKb value of methylamine is lesser than pKb value of aniline, right? But aniline, what happened here? Aniline undergo resonance. What happened? First step, this, the lone pair is shifted here and this move here, right? Minus charge and double bond NH2 plus. Next, this minus bond is go like this. This is a second resonance structure. The second resonance structure is like this, double bond NH2. Then similarly this negative charge is moved and this move like this, right? And this charge move this. Finally we got this structure NH2. It undergo resonance. That's why pKb value of aniline is more than that of methylamine. Second one, ethylamine is soluble in water, whereas aniline is not. Ethylamine structure. What is the ethylamine structure? C2H5 and another H molecule, right students? What happened? Ethylamine, here hydrogen bond is there, that's why it forms an intermolecular bond. It forms an intermolecular bond with water molecule. That's why it bonded. That's why ethylamine is soluble in water compared to aniline. Aniline, what happened? Aniline, it does not, but here also two hydrogen bond is there, but due to phenyl group, due to C6H5 group, it is not soluble in water. It is not allow this hydrogen to form an intermolecular bonding. Understood, students? Third one, methylamine in water reacts with ferric chloride to precipitate hydrate ferric oxide. Methylamine, what is the structure of methylamine? CH3NH2. In water, what happened? Methylamine forms an intermolecular bond with water molecule, right? We already know its bond, it forms an bond with intermolecular bond. It yields CH3NH3 plus. Okay, CH3NH3 plus and also OH minus ion. What happened? Ferric chloride is there. It FeCl3 and it yields this one, right? It ionizes and to form Fe3 plus compound. Then this Fe compound is form and bond with OH minus. Then it yields ferric what? It yields ferric oxide, student. Fe2O3 in the presence of water molecule, XH2O molecule, right? It yields like this. Next, move on to the next one. Although amino group is ortho and para directing in aromatic electrophilic substitution reaction, but aniline or nitration give a substantial amount of meta-nitroaniline. What? Aniline. What is the structure of aniline? But according to us, NH2 group is an what? NH2 group is an para and ortho directing group, but it is not a meta directing group. But in the case of aniline, what happened? We already know nitration. It is placed. Nitration is nothing but HNO3 in the presence of H2SO4. It's nothing but nitration is happens at acidic medium. First, what happened? This NH2 molecule is converted into anilini ion, NH3 plus molecule, anilinium what? Anilinium ion, right, students? Then it undergo nitration in the presence of HNO3 or H2SO4 to yield meta-oriented group. Is nothing but here we already know aniline is basic in nature. That's why it attract or H plus is addition to N molecule. Then it forms a positive ion. Then it undergo nitro substitution. That's why it's an meta-nitro compound is formed. Okay, students. Next one. Aniline does not undergo Friedel-Crafts reaction. It's a very easiest question, right? Aniline. The structure of aniline, we already know about the structure of aniline. This is an structure of aniline, right, student? The structure of aniline. Why? We already know NH2 group is as more pKb value. More pKb value is nothing but it is an basic in nature, right? It's basic in nature. That's why we already know it's nothing but Friedel class. It's nothing but aluminum chloride in the presence of acidic condition. AlCl3 is an acid. Acidic condition. It acts as an acidic condition. That's why Friedel-Crafts reaction is not happened. Next question. Diazonium salts of aromatic amines are more stable than those of aliphatic. It's a very, very easy. What is the structure of diazonium salt? This is an diazonium salt, right? N2 plus molecule. What happened? This undergo resonance, students. It is very easy. It move like this. What happened? This bond is move like this. It forms this. Plus molecule is there. Here minus molecule is coming, right? Then here bond is there. Then it move like that and undergo resonance. It undergo resonance. That's why it is stable. That's why it is more stable compared to aliphatic. What happened? In aliphatic, the resonance structures are limited. It does not undergo resonance. That's why it's an answer. Last one. I think it's a last one. Gabriel phthalimide synthesis is preferred for synthesis primary amines. We already know only primary synthesis. Why? Because if we perform the Gabriel phthalimide synthesis, we get only pure primary amine. That's why we only perform this Gabriel phthalimide synthesis only for primary amines. Understood, student? If you have any doubt, let me know in comment section. First one, arrange the following. First one is in decreasing order of their pKb values. We already know if pKb values is increases, the basicity is increases. Similarly, the basic behavior is increases, pKb values decreases. Let's move on to these four compound. Let's choose as an A, B, C, D. Okay, A, B, C, D. In D compound, here it's an aniline. We already know aniline is more basic. And next move on to this term here. 2 C2H5 group is there. 2 are electron donating group only. That's why here plus I effect is more compared to this two compound. Here only one. Here one also. What? Here one. C2H5 group is there. Ethyl group is there. That's why compared to this is less positive. It gives less positive I effect. That's why we need to arrange in decreasing order of pKb value. Decreasing order is nothing but the decreasing order is the high. This one have high pKb value. We already discussed in previous exercise also. C6H5NH2, it has an highest decrease than. It is decreased than next one. Next one in these three. Next here also aniline group is there. That's why 6,6H5 group is there. Benzene group. That's why next this compound is come. Next here 2. In these two compounds compare here 2C2H5 2 electron donating group is there, but in compound A only one group is there, students. That's why compound A come first, right? C2H5NH2 and last one which is the student C2H5 2NH. Understood? Let's work. Second one in increasing order of their basic strength. Increasing order, students. Here C6NH5NH2. Absolutely, it has a high basic value. Why? It's an aniline. It contains benzene ring. That's why it undergo easily resonance. That's why it has high basic strength. Next, second one, aniline. Then this one, it is also second one is this one, right? C6H5NCH3 2. Third one here. Compared to these two, this compound has low basic strength than this one. Why, students? Here only one electron donating group is there, but here in this 2 electron donating group is there. That's why finally the increasing order is this one, right? C2H5 2 NH2 NH. Yes, let's move on to the third pair. The third one is in increasing order of their basic strength. We have three structures: aniline. What is the structure of aniline? This one. And para-nitro, what? Para-nitro aniline. Para-nitro at para position NO2 group is there. Para-nitro aniline. Para-toluidine, students. Para-toluidine is nothing but this one, right? Para-toluidine. At para position CH3 group is there. Students, here observe. This is an electron withdrawing group and this one is an electron donating group. We need to arrange in increasing order of basic strength. That's why para-nitroaniline is come first. Why? Because it is an electron withdrawing group. It withdraw the electron from this benzene ring, this N molecule also, right? That's why first one is para-nitrotoluidine. It comes para-nitrotoluidine. It have high basic strength. Then next one, second one, it is have low basic strength. Why? Because its pKb value is more. Second one, it's come as an aniline is come. In second one, aniline is come, right? Aniline. NH2. Next, last one, students, it's para-toluidine. In last one, why? Here already one donating group is there. That's why. In this overall exercise is completely depending upon donating and what? Withdrawing group. Here this compound has low compared to this low has high than this one. This is an increasing order. Second one, here aniline group is there. Here also one, these three are there. According to this, yes, aniline comes first. Aniline come first. Yes, aniline come first. Absolutely, C6H5NH2. Next, compared to this here, it is an benzyl amine, students. Benzyl amine. What is the structure of benzyl amine? I write here, okay. Benzyl amine structure is one. It is attached to this group. CH2 group is there in middle. That's why compared to this second group, which second group is coming here? Which one is coming? this one is coming. Why? For N nitro group, directly CH3 group is attached. It's an electron donating group compared to this group. Here CH2 group is there. That's why second one is an what? Second one what we obtained? NHCH3. Last one, it's that's compound. They only give in order. It is easy. Next model, the next one, students. Next one. Arrange in decreasing order of their basic strength in gas phase. In gas phase. Students, observe here. Amine group have an NH3 group have an low basic strength. Sorry, high basic strength compared to all the low. Right? It has an low basic strength. It comes as last. We need to arrange in decreasing order, students. Next, compared to these three, let's move on to these three. Amine group is already clear. Here, this one is aniline group. It has an high basic strength. It compared to amine. Next will come aniline. Then here 3 electron donating group is there. Here 2 is there. That's why first this one is coming. C2H5 3 and second compound, right? Second compound is C2H5 2NH. Understood? Next one, arrange in increasing order of their boiling point. Boiling point compared to this. We already know boiling point of alcohol is higher than compared to higher than amines. Why? Here OH group link is there. OH group, OH bond is there. That's why it has an high. Let's move on to these two terms. Here CH3 2 group is there. Here C2H5 group is there. Compared to this group, this group have an high boiling strength. That's why CH3 2 group is come first, then NH, then C2H5 NH2. Next, move on to the next one, and it is, I think it's an last one, students. In increasing order of what? In increasing order of solubility in water. We already discussed these two are compared to this. Here which one have high solubility? Increasing order. Compared to this, here benzene group is there. We already discussed in previous year, in previous exercise, the aniline group have low solubility in water. Next, compared to here 2 C2H5 2 group is there. Here 1 C2H5 group is there. That's why C2H5 2 group is come first. Why? Compared to this, here intermolecular hydrogen bonding is more compared to this molecule. Finally, we write like this. Understood, students? This is an increasing order of every reaction and every molecule. If you have any doubt about this video, please let me know on comment section. We need to convert. How will you convert ethanoic acid to methanamine? Acid, carboxylic acid group to methanamine group. Ethanoic acid. What is the structure of ethanoic acid? This is a structure of ethanoic acid. What is structure of methanamine? Methanamine, students, it's a very easy CH3NH2. This is structure, right? This is the structure of methanamine. First step, ethanoic acid undergo chlorination in the presence of sulfur chloride. What happened? Here this OH group is replaced by Cl group. Then we get chloro substituted compound. Then next step, it undergo reaction with ammonia, reaction in the presence of ammonia excess ammonia. It yield what? It yield CH3CONH2. Ammonia group is replaced chlorine group. Why? Both are same, only chlorine is also divalent group. That's why. Next, last step, we want CH3NH2. We need to remove this carbon dioxide. How can we remove? By Hoffman bromide test. Br2 in the presence of NaOH. What happened? It releases CO group and we yield methanamine. Yes, CO group get liberated. Okay, students. Next one, hexanitrile N2 1 amino pentane. Hexanitrile. What is the structure of hexanitrile, students? C5H11CN. We already know. We already discussed in previous solutions also. It undergo reduction in the presence of water. What it will be yield? It yield carboxylic acid group. Next step, same procedure, students. Chlorination, C5H11 COCl, then NH3 excess, NH2 excess, ammonia, NH3 excess. NH3 excess, what it will give? C5H11 CONH2. NH2 excess, sorry, NH2 excess, okay? No, NH3 excess only. Yes. Then, last step, Br2 NaOH or KOH. Okay, it's called Hoffman bromide reaction. Bromide reaction, right? Hoffman bromide reaction to yield one amino pentane. One amino pentane is nothing but what is the formula? C5H11NH2. At first position, amino group is present. Third one, students, methanol to ethanoic acid, CH3OH2 C2H5COOH, right? Methanol, right? Methanol. Third one is an methanol to this one. First step is chlorination using PCl5. What it will be? Yield CH3Cl. Next ethanolic NaCN. What it will be? Yield? It react to yield CH3CN group. Cyano substitution group. Then reduction to yield C2H5COOH. Understood? We want ethanoic acid. Sorry, students. It's an propanoic acid, right? We get CH3COOH. Yes. Next, ethanamine to methanamine. What is the structure of ethanamine? C2H5NH3 NH2, sorry, methanamine CH3NH2. First step, NaNO2, it reacted with this one, NaNO2 in the presence of HCl is nothing but azotite test, right, students? It yield what? It yield N2Cl minus, right? N2 plus Cl minus. In what? Unstable compound. It yield unstable compound. Then it undergo reaction with water molecule. What it will be yield? It yields CH alcohol product. Alcohol product H2O is nothing but H plus. Protonation. It undergo protonation to yield alcohol product. Next step is very easy, students. By using alcoholic KMNO4, we can easily convert ethanol to ethanoic acid, right? Ethanol to methanamine. If we convert like this CH3, what it will be yield? It will be yield. Next step, what is the next step? It converts CH3COOH, right? If we convert like this, next step we already discussed in previous also. It is reacted with NH3 excess. Then we get CH3CONH2. Then last step, student. What is the last step? Bromo oxidation reaction, Br2 NaOH to a final ethanamine compound CH3NH2. Yes, CO group get removed. Okay, next one, ethanoic acid into propanoic acid. What is the structure of ethanoic acid? CH3COOH. We need to yield into C2H5COOH. It is called propanoic acid. First step. What is first step? First step, using lithium aluminum hydride and H2O molecule reduction. Reduce the ethanoic acid. If we reduce this, what we get? What we get? Here one oxygen molecule get removed and we get alcohol compound. Then chlorination. In remaining steps are same, student, same step. What it will be? CH3C2Cl, chloro substituted compound. Next step, using ethanol NaCN to yield cyano group CH2CN group. Then protonation to yield propanoic acid CH3CH2COOH. Simple, students. Next one, methanamine to ethanamine. It's nothing but this reverse reaction. First step, ethanamine. What is the structure of ethanamine? Next, first we need to react it with NaNO2 HCl. It yields insoluble compound, insoluble diazo compound, right? CH3 N2 plus Cl minus. As absolutely it's right. Next, protonation to get isocyano compound. No, not an isocyano compound. Protonation to get what? As right, students. Protonation to get alcohol compound, methanol compound. Next, chlorination, CH3Cl group. Next, same, it reacted with ethanol, NaCN, CH3CN group. Then what? Then, right, it reacted with in the presence of NaHG. Okay, then it yield what? It yields C2H5 ethanamine NH2 group. Yes. Clear, students? Next question. Next one, not a next question. I think this one is an last one. Nitromethane to dimethylamine. And also another. Wait, students. And also another one is there. Yes, this one, right? Nitromethane into dimethylamine. What is the structure of nitromethyl? What, students? What is the structure? Nitromethane structure is CH3NO2. First step, we can easily identify the first step. The first step is protonation step. If we protonated, what we get? Amine group. We get amine group. Then next step is it reacted with chloroform in the presence of KOH. It's nothing but carbalamine test. What will yield? Isocyanate compound, right? Isocyanate compound, CH3NC, right, students? Next, it reacts sodium in the presence of C2H5OH to yield diazo compound, CH3. It yield dimethylamine compound. Understood, students? Understood? If you have any doubt, let me know on comment section. Describe a method for the identification of primary, secondary and tertiary amines. Also write chemical equation of reaction involved. We already discussed in previous solution also, students. From using Hinsberg reagent, we can easily identify primary, secondary and tertiary. What is the Hinsberg reagent? What reagent we use? Benzene sulfonyl chloride. It's an Hinsberg reagent, right, students? Hinsberg test. Primary and secondary amines shows positive test for what? Shows positive test for Hinsberg reagent. In tertiary it does not show. Come, let's discuss with the example. First example, let's take, this is a structure of sulfonyl, benzene sulfonyl compound, S double bond O Cl. Then first choose primary amine. Okay, let's come with primary amine. If it's reacted with primary amines, it's nothing but one different R group is there. For example, here taken C2H5 ethyl al group. What happened? This HCl get eliminated and it forms the condensed product, right? Not Cl, here N is there. N adds C2H5. What is the name of this compound? N-ethyl benzene sulfonyl amide. It's correct, students. Let's take an example of secondary amine compound. Any secondary amine? Secondary amine is nothing but the NH2 group is attached to different R group. Instead of here 2H group, place it is attached to different R group. It is replaced by R group. For example, benzene sulfonyl chloride reagent. Plus any example, students. Here one hydrogen compound is there. For example, here both are C2H5. Right. Correct. Then what happened? This HCl group is removed and it obtained this S double bond O and C2H5 and C2H5. Understood, students? Let's move on to the example for tertiary amine. What happened? What is the structure? For example, any tertiary amine. Here it attached to three different group. What happened? Here there is no hydrogen group is there. That's why this is not undergo reaction in the presence of what? In the presence of Hinsberg test, right? That's why primary amine and secondary amine shows positive and tertiary amine shows negative. It does not undergo reaction in the presence of Hinsberg reagent. Understood, student? If you have any doubt, let me know in comment section. Write short notes on the following. First test is an carbalamine reaction. We are already familiar this reaction. Where this reaction is used? This reaction is especially used to differentiate primary amine or secondary amine. What happened? Where aliphatic or aromatic primary amines, for example, let's take an RNH2 as a general form, it's reacted with chloroform. Chloroform is CHCl3 in the presence of ethanolic KOH to yield. What it yields, students? What it yield? Isocyanate compound or carbalamine compound with the KCl molecule and H2O This reaction is called carbolamine reaction. For balancing, we need to write here 3, and also here 3. Understood? Second question, student, diazotization. The name itself it explains diazotization. When primary aromatic amine is converted into diazo salt, this reaction we called as an diazotization. For example, the best example for primary aromatic compound is aniline. When aniline is reacted in the presence of sodium nitrate plus HCl molecule, when it heated, what we yield? Diazotized salt, N2 plus Cl minus compound with the liberation of NaCl compound. Okay, students, it's clear. Let's move to the next one, Hoffman bromide reaction. We already familiar this reaction. What is this reaction? This reaction mainly is used to convert the amide group to amine group, right? For example, amide group, any amide group. For example, let's take an general amide group, RC double bond O NH2 group. We call it an amide group, right, students? This amide group is reacted with bromine. Why? Here already bromide is there, right? Degradation reaction. This reaction is also called Hoffman bromide degradation reaction. What happened? Bromine in the presence of ethanolite, what? Ethanolic NaOH or alcoholic NaOH solution to yield amine with less than 1 carbon in the compound. It yield, right? But here 1 carbon is releases. It is called Hoffman bromide degradation reaction. Understood, students? Next, move on to the next compound, coupling reaction. What is the coupling reaction? Is nothing but if diazotized salt. We already discussed what is diazotization. Diazotized salt is nothing but N2 compound, student, N2 plus Cl minus compound is reacted with aromatic compound to yield coupled reaction. To couple, coupling is reaction is nothing but it is the reaction. It joins two aromatic ring by using N double bond N bond. N double bond N link. This reaction is called coupling reaction. For example, let's take benzene diazotized salt N triple bond N plus Cl minus compound, students, right? It's clear. Then it's reacted with another phenol molecule, OH molecule. Here one H is there, this Cl minus compound it's removed and it forms coupled compound, N double bond N OH compound is simple reaction, right, students? It's clear. Let's move on to the next one, ammonolysis. What? Ammonolysis and acylation, both are there in same only. Let's explain ammonolysis. What is ammonolysis? Ammonium is there. We need to what? Ammonolysis is nothing but when an alkyl or aryl chloride, for example, let's convert, it's reacted with RX allied molecule. What happened? It forms R2NH compound. Then another molecule it's reacted. Amine compound is reacted with allied compound to yield this compound, right? R3N compound. Then further on reacted with RX compound. What it yield? Quarter ammonium salt, R3N plus X minus. This is called quarter ammonium salt. This quarter ammonium salt is nothing but NH3 plus X minus compound is reacted with alcoholic NaOH solution, students. Alcoholic NaOH solution to yield RNH2 to yield amine compound. This reaction is called ammonolysis. Acylation is also there. The name itself, we are already familiar with this reaction in previous exercise, in previous unit also. Acylation is nothing but acyl group. Acyl group is added to a compound. For example, let's take any one amine group. Here H group is there, another H group. Here already no one lone pair of electron is there. It's reacted with acetyl chloride, students, CH3 compound. What happened? This it attacked to the carbon molecule and this bond is moved to the oxygen molecule. Then it yields CCH3O minus Cl compound with R and HH, right? Then it move like that and we form final compound as in this, right? RNH2 compound with CCH3 and double bond O. This is a final compound. This process is called acylation. In this process we add acyl group, CH3 group to a compound, OCH3 group to a compound. Clear, students? Yes. Let's move to the last one, Gabriel phthalimide synthesis. What is Gabriel phthalimide synthesis? Already phthalimide compound is there. We already familiar this reaction. This reaction is mainly used to form the aliphatic primary compound. Yes, it is famous to prepare aliphatic. It's a convenient manner. It's an easy process to prepare aliphatic. What is it's nothing but it's prepare aliphatic primary amines. I already explain you guys phthalimide. What is the structure of phthalimide? For benzene group, here one C double bond O group is there. This is an phthalimide compound. If it's further reacted with potassium KOH solution, alcoholic KOH solution to yield potassium salts of a phthalimide. Potassium salt, students, C double bond O, N minus K plus. Potassium always positive charge. Why? It's an high reactive metal. We already familiar. Then it further on reacted with halides to yield phthalimide substituted halide compound NR compound. Right, students? Next, it further on hydrolysis using NaOH compound to yield primary amine and sodium salt of phthalic acid. C double bond O, Na compound. C double bond O, Na compound. As O minus Na plus. We need to write the charges also, students. It's important with the release of primary compound. Aliphatic compound, primary compound. As clear? Accomplish the following conversion. The first one, benzene to benzoic acid. What is the structure of benzene? This is the structure of nitrobenzene, right? To convert benzoic acid, we are already familiar with application of diazonium chloride salt. If we convert nitrobenzene to diazonium chloride salt, we can easily convert to benzoic acid. For that, first step is an catalytic hydrogenation. It yields aniline, right, students? It yields aniline compound. Then, if it's reacted with HNO2, it's nothing but nitrous acid. How to obtain nitrous acid is nothing but NaNO2, sodium nitrate. It reacted with HCl plus HCl to give diazonium chloride salt, N2 plus Cl minus. Then it's reacted with KCN molecule to convert to obtain benzene cyanonitrile compound, right? Then if it undergo hydrolysis to yield benzoic acid compound, it undergo hydrolysis to yield benzoic acid compound. I hope it's clear. Second one, benzene to metabromophenol. What is the structure of benzene? Students, we are already familiar. Nitrobenzene is a meta-oriented group. First, we convert benzene to nitrobenzene. It is nothing but it reacted with nitration, students. Benzene reacted with HNO3 and H2SO4, concentrated HNO3 and concentrated H2SO4 to yield nitrobenzene compound. Then bromination, Br2. It yield bromination. We already know nitrobenzene group is an meta-oriented group. That's why we obtain bromo group, but we want phenol group. Same, students. It undergo catalytic hydrogenation to yield aniline compound, right? It yield aniline, bromoaniline, metabromoaniline. Then it reacted with nitrous acid to yield diazonium chloride salt, N2 plus Cl minus and Br. The same compound, it reacted with dilute H2SO4 to yield metaphenol compound, metabromophenol compound, phenol. Okay, I hope it's clear. Let's move to the next one. Benzoic acid to aniline. It's nothing but reverse of the first question, reverse of the first conversion. Okay, what is the structure of benzoic acid? This is right. First step is very simple. We need to convert benzoic acid to chlorosubstituting group. Substitute group. How can we convert? By using sulfonyl chloride, SOCl2. What happened? COCl compound, chlorosubstituting group is formed. Next step is very simple, amination, NH3 group. If it's reacted with NH3 group, we obtain CONH2, amine group, right? Then Hoffman bromo degradation reaction is nothing but this compound is reacted with bromine NaOH, Br2 in the presence of NaOH to yield aniline compound. It's a very simple reaction. Let's move to the next one. Aniline to 2,4,6 tribromofluorobenzene. Aniline, what is the structure of aniline? This is a structure of aniline, right? We already know aniline is an ortho and para-oriented group. If we want bromo compound, that's why it reacted with bromine water, Br2 in the presence of H2O. It yield ortho and para substituting para bromo group. bromo group is substituted in ortho and para group. Alright, students. Then, but we want what we want. We want fluoro compound. That's why it's reacted with HNO2 compound. Right? If it's nitrous acid is reacted, it yield N2 plus Cl minus compound. With 3 Beer group, students. Beer group is very important. Please do not forget. Why? Because we want tribromo compound. That's why. Next, it is reacted with HbF4. What it give? Cl minus compound is replaced by BF4 minus compound to yield this compound, right? N2 plus and BF4 minus. Hydrogen bromofluoride, students. We are already familiar this reaction in before unit also. Sorry, here Beer group is there. Here Beer group and another Beer group. Then this one we want bromo group. That's why if we eat the compound, we obtain the fluoro compound. This is a final structure. This is a conversion. Let's move on to the next one, students. What is the next one? Come on, let's discuss. Benzyl chloride to 2-phenyl ethanamine. Benzyl chloride. What is the structure of benzyl chloride? Benzyl chloride is nothing but CH2Cl group. Okay. First step, we need to convert Cl group to cyanonitrile group. It's nothing but by using ethanolic NaOH solution. If it's heated or if it's react with, it give benzyl cyano compound CH2CN. Then if it's reacted or if it's undergo nickel catalytic hydrogenation reaction to yield our compound 2-phenyl CH2CH2CN. Not an CN, here NH2 amine. I hope it's clear. Last one, chlorobenzene to parachloroaniline. Students, here one important point is there. We are already familiar with halogen group. Halogen group, if it attached to aliphatic ring. Aliphatic is nothing but straight chain or branched chain. It acts as an electron withdrawing, right? But instead of aliphatic, it is attached to aromatic. It acts as an electron donating group. That's why chloro group is an ortho and para oriented group, right, students? Similar as an NH2 group. That's why if it undergo what we want aniline. If we obtain para chloro nitrobenzene, we can easily convert to aniline by using palladium or nickel catalytic hydrogenation. Okay, students, come on, let's convert into an. It's undergo nitration in the presence of concentrated HNO3 and concentrated H2SO4. It yield 2 nitro substitute group, one at para position and another one at ortho position. Okay, these are the 2 groups. But what we want parachloroaniline. That's why this first A compound is reacted with, it undergo catalytic hydrogenation by using H2PD, palladium catalyst. It yield aniline compound, NH2Cl compound. Give the structures of A, B, C for the following reaction. We need to identify the A, B, C. Okay, what happened if iodo substituted or chloro or any allo substituted group, it undergo NaCN, it reacted with NaCN. What happened? Chloro or halogen substituted group is replaced by CN group, right? It yield cyano compound. As partial hydrolysis, students, what is the meaning of partial hydrolysis? If we cyano compound undergo partial hydrolysis, what it yield? It yield amide group, students. Propanamide, CH3, C double bond O NH2. S, this is an B. Last, NaOH Br2. What? Hoffman degradation reaction. Hoffman bromo degradation reaction to yield amine compound. CH3, CH2, CH, NH2, right? CH3, CH2, NH2. It yield amine compound. As it's clear, let's move to the second one. C6H5 N2Cl is nothing but N2 plus Cl minus. Diazonium chloride salt. If it's reacted with CuCN, we already in previous exercise we already discussed about the conversion, right? Conversion. From using that we can write, this N2 plus Cl minus compound is replaced by CN group. Cyanobenzamine, right? Cyano group is formed. Next, it undergo hydrolysis. It's nothing but what it yield? It yield benzoic acid, right? Benzoic acid. Then amination is there, student. Amination, it nothing but what it yields. Last compound is amide group, C double bond O NH2 group. I hope it's clear. Let's move on to the third one. Yes, same. Bromo group is replaced by KCN. It's nothing but CH3, CH2. CN. But here LiAlH4. What is this? It's an reducing agent. It helps to compound to reduce. It's nothing but what it yield. If it reduce, it give amine compound, propanamine, right? CH2, CH2, NH2. Right, students? This is B. Then it's reacted with HNO2. Students, here concept is different. If it's aliphatic amine, it give alcohol, right? C compound is an alcohol. If it give propanol. But instead of this, if it's an benzene group or aromatic ring, it gives benzone or diazonium chloride salt. Right, students? Let's move on to here. NO2. Iron in the presence of HCl, it acts as reducing agent. That's why it give aniline. Then NaNO2 plus HCl. It's nothing but HNO2, right? It's nothing but it give what it gives, students? Dibenzonium chloride salt. N2 plus Cl minus. Then hydrolysis for this, it give phenol compound. I hope it's clear. Let's move to the next one. Acetic acid, it's reacted with NH3 group A. It's nothing but it's an amide group. It yield amide group. Then if it's reacted with NaOBr, same, students, right? It give what it give? It give amine compound. Amide to amine. Hoffman degradation, right? Hoffman bromine degradation reaction. It yields CH3NH2 compound. Then alcohol. I hope it's clear. Last one, students, NO2, same step. It yield aniline compound. Then B, HNO2 is nothing but it yield what it yield? Diazonium chloride salt. Then C6H5. It's nothing but it reacted with phenol compound. What it yield? It undergo coupling reaction to yield the compound, to yield the coupled product. N double bond 1, 2 aromatic ring is connected with N double bond 1 and OH group. It's clear, students. What is the name of this compound? The name of this compound is para-hydroxy azobenzene. I hope it's clear, student. If you have any doubt, let me know on chat section. An aromatic compound A on treatment with aqueous ammonia and eating forms compound B. Some compound B, it is also aromatic. Why? They give only A is an aromatic. Aromatic compound give aromatic product. We already know that. Which on eating with Br2 and KOH forms an compound C of molecular formula C6H7N. Write the structure and IUPAC name of the compound A, B and C. We need to identify the structure of A, B and C with the name. It's very simple. What is the product? C. C6. They give molecular formula like this, right, students? It is nothing but it's an aniline compound. It's an aniline. We can easily identify the aniline compound, right, students? Next, first move on to the before step. It's nothing but B compound. What happened? How to obtain aniline from using Br2KOH? Hoffman bromo degradation reaction, student, is nothing but we already familiar. We already discussed so many exercise on the basis of Hoffman bromo degradation reaction. That's why it's nothing but it is an amide group, students. C double bond O NH2 group. Next, we need to identify first one. A1 is what treatment with aqueous ammonia is nothing but amination. Is nothing but the compound is COOH, benzoic acid. Here, if it's reacted with aqueous NH3 compound, OH compound is replaced by NH2 compound to yield benzamide compound. What is the IUPAC name is for this? B, benzamide. A, benzoic acid. Last one, aniline. I hope it's clear, students. Complete the following reaction. We already discussed conversion, name and everything. Let's move to the complete the following reaction. We need to complete the reaction. First one, aniline compound react with chloroform and KOH molecule is nothing but it's an carbalamine reaction. That's why it is isocyano compound C6H5CN compound with KCl molecule and also water molecule. I hope it's clear. Second one, it's an application of diazonium chloride salt. Benzene diazonium chloride is reacted with H3PO2. It's nothing but hypophosphoric acid in the presence of water. It gives benzene compound, right, student? Benzene with N2 gas liberated, H3PO3 molecule and also HCl, hydrogen chloride. Third one, Aniline is reacted with H2SO4, concentrated H2SO4. What it yield? It yield one simple different compound, NH2 plus and HSO4 minus. Right, students? What is the name of this compound? The name of this compound is aniline hydrogen sulfate. I write in bracket aniline hydrogen sulfate. Okay, students? Next, more on the next one. Same application of dibenzonium chloride salt only. The benzene diazonium chloride salt is reacted with alcohol molecule. We already familiar this reaction, right, students? What is the final product? Yield one benzene molecule, right? And also one aldehyde compound. What is the aldehyde compound? C2H5 COH, and also with it yield what it yield? N2 compound and HCl compound. Right, students? Next one we already discussed in previous exercise also. Next one is aniline reacted with bromo compound. NH2 group is an NH2 group is an ortho and para oriented group. That's why it yield. I write the answer in here. Okay. Tribromo aniline compound. This for fourth one. Tribromo aniline NH2. Sorry. Okay. It's clear. Next one. Aniline is reacted with acetic anhydride. What it yield? It yield different compound, students. The N-phenyl ethanamide. Right, student? What is the structure? C6H5NH. It yield amide compound, students. 3 double bond O NH2 with acetic acid. CH3COOH. Last one is an diazonium salt. It's reacted with HbF4 and in the presence of NaNO2 and Cu. What it yield? Let's discuss. Come on. It yield nitrobenzene and N2 compound with sodium bromofluoride. As it's clear, I hope it's clear. If you have any doubt, let me know in comment section. Why cannot aromatic primary amines be prepared by Gabriel-Thallimide synthesis? We are already familiar with Gabriel-Thallimide synthesis. We cannot prepare aromatic. We prepare aliphatic. Why? Why not aromatic? Why? Because Gabriel-Thallimide synthesis, it involves SN2 mechanism, right? It involves SN2 mechanism. It's nothing but Gabriel-Thallimide synthesis, nothing but thallimide compound. This is a structure of thallimide, right? C double bond O and H compound. It reacted with KOH molecule to yield potassium salt. Potassium substitute thallimide compound. Then we need to react this compound N minus K plus here SN2 compound is react. SN2 mechanism is there. It involves SN2 mechanism. That's why if it's reacted with aromatic allied group, it gives no reaction. That's why we cannot prepare aromatic primary amines in Gabriel-Thallimide synthesis. I hope it understand. If you not understand and if you have any doubt, let me know in comment section. Write the reaction of aromatic and aliphatic primary amines with nitrous acid. Come on, let's discuss first one, aromatic. Aromatic and aliphatic. Let's choose an aromatic as an here. We need to choose NH2 compound, right? Aromatic and aliphatic primary amines. The best example is aniline, right? It's reacted with HNO2 compound in the presence of NaNO2 and HCl. This is very important. If sodium nitrate is reacted with mineral acid to yield HNO2, nitric acid, nitrous acid, we already familiar. What it yield? Diazonium chloride salt. As we already familiar this reaction in before exercise also with NaCl compound, right? NaCl and H2O compound. Let's move to the primary point. Aliphatic primary amines. RNH2. Here R is an aliphatic compound. Okay. It's reacted with nitrous acid. NaNO2 HCl. Here also, students, here also same compound diazonium chloride salt only yield. But you know one thing, after some time, after the reaction is never stop this process. But here for aromatic it stop this process. Then depends upon the other reactant, then it undergoes reaction. For example, if you take CN compound, it is replaced by overall N2 plus Cl and form benzene cyano compound. But here what happened? Further it reacted H2O molecule. H2O molecule is formed in subproduct. Now it also reacted with to form alcohol compound with elimination of N2 gas and HCl compound. This thing is happen. In aromatic, we obtain diazonium chloride salt. In aliphatic also, obviously we obtain the salt, but after it undergo reaction with this a product only to yield alcohol compound. This is about this solution. If you have any doubt, let me know on comment section. Give plausible explanation for each of the following. We need to explain, right? First one, why are amines less acidic than alcohols comparable molecular masses? Both have comparable molecular masses only, but why? Alcohols are highly acidic. What is the structure of alcohol? ROH, right? What it forms? It forms RO minus compound, and also amines RNH minus compound. Here students, the negative charge is held by nitrogen in amine compound, oxygen in alcohol compound. We already know oxygen is always have high electronegative charge, and also it compared to nitrogen, it has more capacity to hold the negative charge. That's why always alcohols are highly acidic. I hope it's clear. Second one, why do primary amines have higher boiling point than tertiary amines? Absolutely, primary amines have high boiling point. Why? We are already familiar. What is the structure of primary amines? It attached to only one different R group compared to others. Tertiary amines is it attached to all three H group. It is replaced by R group. We already know what happened here. Here, intermolecular hydrogen bonding is formed between another compounds like this. Okay, like this, and another H compound like this. It forms like this. That's why we need high energy to break the bond. Nitrogen and hydrogen bond. That's why primary amines always have high boiling point. Last one students, why are aliphatic amines stronger bases than aromatic amines? Why? What is the structure of aromatic amines? For aromatic, here benzene group is there, right? Benzene group gives negative I effect or negative R effect, negative resonance effect. That's why compared to aromatic, always aliphatic amines stronger bases. Okay students, due to negative R effect. I hope it's clear. If you have any doubt, let me know on comment section, and please do not forget to like, share and subscribe the channel for more updates. Bye.